All right, let's get started. You should all have the guided notes for 3.5, and you can see that the problem of the day is right here for you. Okay, so I would like the sub to pause for about 3 minutes while you attempt to answer A and B. At the end of 3 minutes, the sub will press play and we can go through this together. Okay, so for this exponential equation, it is saying that S is the amount of spending in billions and T represents 2011. So if we want to know T equals 11 represents 2011. So if we want the spending in 2013, that means we are going to need to plug 13 into our equation. When you type that into your calculator, you should get 40.355. But remember, this means billions of dollars. So you need a dollar sign, and this represents billions. Okay, so we have 40.355 billions of dollars. All right. Now, in what year did the U.S. spend $80 billion? Okay. Well, that is where you are going to have to go ahead and set your equation equal to 80. Oops, sorry. Okay. And use what you know about solving equations to help you. Okay. Hold on a moment here, guys. Okay. Okay. So what we're going to have to do is divide over the 9.3. Then you're going to have to rewrite it as a logarithm. So you should have the natural log of 80 divided by 9.3 equals 0.1129t. You can type this into your calculator, divide by the 0.1129 to get t is 19.06. So since 19.06 is t, then during the year 2019, that would be when the U.S. spent $80 billion. Okay? Even if that was 19.9, it would still be during the year 2019. Okay? Once it hits 20, then we get to that year of 2020. Right? Okay. Today we are going to talk about exponential and logarithmic models, and I have for you a guided note sheet because we're going to be talking about a lot of application problems. Okay, so I have these written out for you. Now, the first thing I want to go back and talk about is the concept of compound interest. Okay, so we talked about finding an amount in compound interest. Well, what if we are asked for, in this case, how long will it take? Okay. Well, how long will it take means we are solving for t. Okay. So how long will it take an investment of $1,000 to double if your interest is 8%? So we are investing $1,000. That means P is 1,000. And if we want our investment to double, that means the amount is going to be 2,000. Okay? Now our rate is 0.08. Remember, you do have to convert that to a decimal. And if we're doing this quarterly, that means N is 4. It's happening 4 times a year. Okay? So when we plug into our formula, we would have 2,000 equals 1,000, that's our P. 1 plus 0.08 divided by 4 raised to the 4t. Okay, now, one plus 0.08 divided by 4. We know that 0.08 divided by 4 would be 0.02, and if we add 1, we get 1.02. Okay, I think we can all do that. And to solve for t, we're going to have to get this exponential piece by itself. So we're going to want to take this 1,000 and you're going to want to divide it over. So if we divide it over, we would have 2 equals 1.02 raised to the 4t power. Now I want you to notice something here. We are finding how long it's going to take for our investment to double. It is no coincidence that this number right here is 2. If our investment was going to triple, then the amount divided by the principal would be 3. All right? That's going to happen. Now what we can do, since we have our base to a power alone, we can rewrite this as a logarithm. So we can write this as log base 1.02. I know it's awkward, but that is the base for the exponent of 2 equals 4t. Okay? So with the change of base formula, you can push log 2 divided by log of 1.02. Once you get that value, to get t by itself, you would need to divide by 4. So t is 8.75 years. Now I also want us to determine how long it's going to take our investment to double if it is compounded continuously. Okay, now we talked about the other day how if it's compounded continuously, we're going to make more money quicker. So we can expect that it will take us less time to get our investment to double. Do you agree? So we're going to do the same thing. We have A equals P E to the RT. Okay, so we have A equals P E to the RT. So we can once again divide that 1,000 over, so we have 2 equals E to the RT. Okay, so since we have our exponential piece to itself, we can rewrite it as a logarithm. So log base E of 2 equals 0.08t. So what we can do is we can punch the natural log of 2 into your calculator. I am assuming you are doing that along with me. Punch natural log of 2 into your calculator. Divide both sides by 0.08 to get a time of 8.66 years. Okay? And as I mentioned, it is going to take less time for continuous compounding to double than it would for any other type. Okay? The more times you compound, the quicker you're going to get your investment. All right? So now, let's talk about the different exponential models that we have. Okay, you have 3 graphs below there. All right? Exponential growth we have when we have a positive exponent to an exponential equation. And we're going to work with e as our exponential function. Okay? So if we have y equals a times e to the bx, where b is positive, that means we have exponential growth. Now, we're going to kind of relate this back to our PERT equation. Okay, y is always going to stand for the amount of whatever we are dealing with. Okay, we might look at some half-life problems, we might look at some population problems. So y is the amount after, whatever our variable is. If it's x, it could be days, it could be months, it could be seconds, we don't know. And so that is up to interpretation depending on the problem. Now, A is always going to be your initial amount, just similar to what P is for PERT, okay? And B is always going to be your rate. So in this case, since B is positive, we have exponential growth. Whereas if we go to this equation over here, B is negative, which means we have exponential decay. All right, so for these two, they're going to be the same. Your exponent, the coefficient of your exponent is going to be your rate. The coefficient in front of E is going to be your initial amount. All right, and so if B is negative, we just have exponential decay. And this funky looking graph, this is called logistic growth. Okay, we still have the same thing with our variables here, A being that initial amount. However, what's happening in a logistic growth model is it's always growing, but it grows quickly, but then it slows down and continues to grow, okay? So you're going to see like the spread of diseases follow a logistic growth model sometimes. Spreading rumors will follow kind of that logistic growth model, okay? What I'm going to expect you to be able to do with this is if I give you something already in this model, can you work with it? Whereas over here, these two, I'm going to expect you to be able to come up with an equation, all right? So we have two examples on the back that we're going to do. Example number 2, which is that first one that you'll find, deals with writing the equation of an exponential model, okay? Let's read through this together. In a research experiment, a population of fruit flies is increasing according to the law of exponential growth. All right, so I'm going to just stop right there. Y equals A e to the B x. Exponential growth. Okay. After 2 days, there are 100 flies, and after 4 days, there are 300 flies. How many flies will there be after 5 days? Okay. Now, what I'm going to go ahead and do, because I know we like to think of R as rate, I'm going to go ahead and change, instead of Bx, we're going to change this to Rx, just because I think we will all be more comfortable with thinking of rate as R. Okay. So, after 2 days, there are 100 flies. So what I'm going to go ahead and do is I'm going to define our variable to be Y is the number of flies after X number of days. Okay? And if that's the case, then we can say, all right, after 2 days, there are 100 flies. So I put 2 in for X and 100 in for Y. Also, there are 300 flies after 4 days. Okay. Now we have to figure out what is our rate, all right? And eventually we're going to have to figure out what our initial amount is, okay? So the first thing we need to worry about is R. What is R? We need to solve these equations for R so that we can write this equation right here. Well, we also need to figure out what A is so we can write this equation right here. So we have 2 variables and 2 unknowns. That is not something you have not seen before, all right? What we're going to have to do is solve one equation for a variable and plug it into the other. For example, I can solve this equation right here for A. I can say A is 100, and I can divide e to the 2r over to the other side. What can we do with that? We can take this A, and we can plug it over here into this A. All right? So what we have is 300 equals A times, I'm going to write this as e to the 4r. It just looks better that way. Okay. Well, now let's talk about some exponent rules. Okay. I have 100 divided by e to the 2r times e to the 4r. This is the same thing as like over 1. So what we have is 300 equals 100. If I have e to the 4r and I'm dividing by e to the 2r, then we subtract exponents to get e to the 2r. Okay, now we have a nice way to solve for r. All right, we can divide this 100 over. Now that we have e to the power, we can go ahead and rewrite. So we can rewrite this as log base e of 3 equals 2r. So our rate is the natural log of 3 divided by 2, or we can go ahead and write it as 0.5493. Okay, now we also need a to write our equation. So I'm going to take this right here and we're going to come back to here. Well, I know a is 100 over e to the 2r. So if I go ahead and plug in r, which is the natural log of 3 over 2, okay, or you can plug in your decimal. I don't care what you do. I'm going to go ahead and plug in the exact value. But if we go ahead and plug that in for r and plug this into our calculator right here, we get that our a value is 100 over 3. So what we have now is that y, the number of flies, is a 100 over 3, e to the r x power. Okay. So if we want to know how many flies after 5 days, then what we can do is we can plug in 5 to x, type that into our calculator, so that we get 519.6 flies. Okay, one last example here. Okay. On a college campus of 5,000 students, one student returns from vacation with a contagious and long-lasting flu virus. The spreading of the virus is modeled by this equation here. And what's interesting about this equation is this 5,000, this is what's called the carrying capacity. That's the most, that's the maximum number of students that could get the disease, because there are 5,000 students on campus. Okay. Why is the total number of students affected after, so why is the total number of students affected after T number of days? The college will cancel classes when 40% or more of the students are infected. So the first thing that we need to do is figure out how many students are infected after 5 days. So how many students, that means we are looking for y, and after 5 days, that means our time, T, is 5. So all we need to do here is plug 5 in to our equation. Now everybody needs to practice this to make sure that they can get the correct answer. Since we have more than one term in the denominator, please make sure you are putting the denominator in parentheses. So we have 54 students infected after 5 days. Okay. Next, what we need to do is figure out when they are going to cancel classes. Okay, so I'm gonna all right, sorry, I'm having trouble with my board here, so just bear with me. All right, so after how many days will college cancel classes? Well, they said 40% of the students needed to be infected for them to cancel school. So what is 40% of 5,000? Okay. Hopefully you are all saying quietly or loudly, I don't know, 2,000 students. So what we need to do is we need to take this equation and we need to set it equal to 2,000. So we have 2,000 equals 5,000 divided by 1 plus 4,999e to the negative 0. Okay, that is what we need to solve. Okay, so my first piece of advice would be to multiply this over so that we no longer are working with a fraction. And then I would go ahead and take this 2,000 and divide it over. So we have 1 plus 4,999e to the negative 0.8t equals 5/2, right? 2.5 would be fine. All right. Then I'm going to take this 1 and subtract it over. Okay. We still need to get that exponential piece by itself, so we can go ahead and divide by that 4,999. Okay. Now I know this is going to look ridiculous, but I want to make sure we're getting as close to an accurate value as we can. So I'm just going to leave it like this for now. And when we rewrite this into exponential form, or excuse me, logarithmic form, we're going to say log base e of 1.5 divided by 4,999 equals negative 0.8t. So what I'd like you to do is go ahead and type in the natural log of 1.5 divided by that 4,999. Okay, and with that we can go ahead and divide by the negative 0.8. Okay, so by the 10th day we're going to need to cancel classes. Okay, which is not a lot of time. Okay. So, whatever time is remaining in the class period, I expect you to have your books open. You can share at your pod, that is not a problem. But you need to be working on the gold sheet problems that I have assigned you. First, work on the bolded ones, and if you still aren't feeling comfortable, work on the non-bolded ones. Okay? You all are to work until the end of the bell. We will go over any questions tomorrow. Have a great day.